Good day students. In this video lecture, you will understand how to represent a continuous time signal in terms of unit step and unit ramp function. You know unit step function is given by u of t equal to 1 for t is greater than 0 and 0 for t is lesser than 0. Graphically it is represented like this. You will have 1 starting from 0 to infinity of time. You will have 1 with the amplitude is 1. So this is the point of discontinuity. Unit ramp function is given by r of t equal to t for t is greater than or equal to 0 and 0 for t is lesser than 0. R of t graphically is represented like this. It is starting at 0, goes to infinity. When you apply t, when at time t is 0, r of t is also 0. Time 1, it's 1, 2, it's 2. It's like that. So its amplitude will be like this. So it's a linear signal which is increasing with the slope of 1. Okay. This is u of t and r of t function. Now we will understand, given a continuous time signal, how to represent the continuous time signal just by having the knowledge, just by u of t and r of t. So before going into that, you have to understand wherever continuous time signal is having discontinuity, then you are going to represent by u of t, and wherever slope is there, you will represent it by r of t. So let us start with a simple example. So this is a pulse signal starting from 0 to 4 with amplitude is 1. You can see, so whenever you are trying to represent, so what you need to do is, you need to start from leftmost and go towards the right side. So you can see in this case, left side there is no signal, you are having all the signal only in the right side. So your first signal is starting at 0, signal is ending at 4, and you can see there are two discontinuities. One is at this place, another one is at this place. So these are two discontinuities. So this signal can be represented only by u of t, not by r of t. Okay. So before going into this, what you need to do is you have to find out what is the amplitude change at these discontinuities. So amplitude change in the sense, it is going from 0 to 1. So present value is 1, previous value is 0. So 1 minus 0, the amplitude change is 1. Here amplitude changes, present value is 0, previous value is 1. So 0 minus 1, it's minus 1. So when you start to represent, what you can do, this is the signal starting at 0 with the amplitude change is 1. So this can be written as u of t. From this point, it's starting with u of t and it is ending at, so you can say the signal is not continuously keep going. It's ending at 4. There is a signal change at 4. So you need to represent that is again a discontinuity. So this again will be represented by u of t only. At time t is equal to 4, amplitude is changing by minus 1. So this will be given as minus u of t minus 4. The same thing only. If you are having a signal in the left hand side, say for example minus 2 to plus 2, you are having a signal in left hand side. As I told you earlier, you are starting from leftmost side, go towards rightmost side, and this is the one place of discontinuity. This is the second place of discontinuity. It's a constant signal. Okay, it's a constant signal. Okay, so again you will understand what you will do is you will find out what is the amplitude change. So from 1 minus 0, amplitude change is 1. Present value here is 0 minus 1, the amplitude change is minus 1. So you are starting from the leftmost side, you are having the signal at minus 2. So you will write it as, the amplitude change is 1. So you will write it as u of t plus 2. And the signal changes, next signal change you are finding at time t is equal to 2 at this point. So the slope, the amplitude is minus 1. So you write it as minus 1 times of u of t minus 2. This is the representation of this signal. Now let us take another one example. Simple case. This example 1, 2, 3. Say for example 1, 2, 3. Let this be 1. Let this be 3. Now again there is no signal till 1. After 1 only you are having a discontinuity, and discontinuity, the slope is, or slope you can call it as an amplitude change is 1 here. Here you are having second discontinuity point. Here amplitude change is, present value is 3, previous value is 1. 3 minus 1, amplitude change is 2. Here you are having a third discontinuity. Present value is 0, previous value is 3. So it's minus 3. Okay. So now what you will do, you will start again, you are having only discontinuity, therefore you will represent everything only by u of t. So it's starting at time t is equal to 1 with the amplitude change is 1, so you will write it as u of t minus 1 plus, again you are having a signal change at the time t is equal to 2 and the amplitude change is 2, so you will write it as 2 times of u of t minus 2. Then you are finding the third signal is changing from this point. At this point, it's changing from 3 to 0. The amplitude change is minus 3. Sorry, this is not plus 3 because from 0 minus of 3, it's minus 3. Amplitude change is minus 3. And it is happening at the time t is equal to 3. So you will write it as minus 3 u of t minus 3. Now, if you want to validate your signal, what you can do is you can apply sometimes. Say for example, let us apply t is equal to 2.5. 2.5 we know it's at this place. At this place our amplitude is 3. So, if you apply t is equal to 2.5, you should get the result of this equation should be 3. So, now if you apply t equal to 2.5, this first expression becomes u of 1.5 plus 2 times of u of 0.5 minus 3 times of u of minus 0.5. So you know that unit step signal is not existing at less than 0. So u of minus 0.5 will give you answer is 0. Whereas greater than 0, whatever is the value, the result is 1, unit step signal. So u of 1.5 is also 1. U of 0.5 is also 1 multiplied by 2. So which is equal to 3. Okay. So let us validate in some other point. Say for example, you take it at 1.5. So let us find out what is the value at t is equal to 1.5. You apply in this equation. So first expression, it becomes u of 0.5 because 1.5 minus 1. Second expression plus 2 times of u of 1.5 minus 2 is minus 0.5. Third expression u of t minus 3. So 1.5 minus 3 is minus 1.5. So this you can write it as minus 3 u of minus 1.5. As I told you, u of t does not exist in negative side, so this will get cancelled, this will get cancelled. You are having only u of 0.5. You know u of 0.5 or any value u greater than 0 will give you answer is 1. So you can find here at 1.5 you are having the answer is 1. Okay. Now let us do one more example. Say for example, we have a signal like this. We have a signal like this. Let us say this is at minus 1, this is 0, this is plus 1. Let us say this is amplitude is 1, here the amplitude is minus 2. Now again what you have to check? You have to check whether you are having any slope or you are having only discontinuities. So you can see in this case also you are having only discontinuities, 3 discontinuities, one at minus 1, another one at 0, another one at plus 1. So what you need to do is you need to start from leftmost side and you have to travel towards rightmost side. And before going, you have to understand what is the amplitude change. So at minus 1, you find it's going from 0 to 1. So amplitude change is plus 1. And at 0, it is going from 1 to minus 2. So present value is minus 2, previous value is 1. So minus 2 minus of 1 will give you minus 3. So at this discontinuities, your amplitude changes minus 3. Similarly, at this discontinuities, the amplitude is coming from minus 2 and reaching the answer 0. So 0 is the present, minus 2 is the previous, 0 minus of minus 2 gives you plus 2. So amplitude change here it is plus 2. Now when you are trying to represent the signal, everything is you are representing only with respect to u of t. So at this point you will write it as amplitude change is 1. So this can be written as u of t plus 1. Plus 1 because it's starting at minus 1. Then you can see next amplitude change is happening. Signal change is happening at 0. Time t is equal to 0. And the signal amplitude change is minus 3. So you will write it as minus 3 u of t. And next you will find the signal change is happening at 1. And the amplitude change is 2 plus 2. Then therefore you will write it as plus 2 u of t plus minus 1. This is the expression for this signal. You can also validate the signal. Say for example, let us say at a 0.5, you want to find out what is the value at t is equal to 0.5. You apply in this equation. So first expression becomes t is equal to 0.5 plus 1. This becomes u of 1.5 minus 3 u of 0.5 plus 2 u of minus 0.5. So you know very well, unit step signal will not extend in the negative side. So this term becomes 0. And unit step signal greater than 0, whatever is the value inside the parenthesis, the answer is 1. So it's greater than 0, time is greater than 0. So u of 0.5 is also 1, u of 1.5 is also 1. So 1 minus 3 times of 1 gives you the answer is minus 2. You can even take any place and you can even validate the signal also. Okay. Now let us start with the ramp. Again I am starting with a simple signal. This is the ramp. One, you are having increasing ramp and also you are having decreasing ramp. So in the case of the ramp, what you need to do is, instead of finding amplitude change, you have to find out the slope change. Slope change. So say for example, if this peak is 1. So what you need to do? dy by dx. In dy, what is the difference in y-axis divided by difference in x-axis? Difference in y-axis is also 1, difference in x-axis is also 1, 1 by 1, and it is increasing, so it's a positive 1. The slope for this is positive 1. Similarly here, you can see that in x-axis also 1 to 2, difference is 1, y-axis also 0 to 1, difference is 1. So dy by dx, if you apply 1 divided by 1, but it's in the decreasing order, so it's minus 1. So these are the two slopes. Now, when you are writing for the ramp signal, what you need to understand is, you are not only finding out the amplitude slope at this point, you will always write the amplitude change is something but the slope change. Okay. So again you are starting from negative side, you will move towards the positive side. You are starting at 0. Just a minute. You are starting at 0. From 0 till 1, it's an increasing ramp. So it's given by r of t. And amplitude is 1 or slope is 1. Okay. And at 1, it started to decrease till 2. Therefore, now at this point, what you need to do is, you need to find out what is the slope change. Okay. So the slope change from positive 1, it is changing to negative 1. So current slope is minus 1. Previous slope is plus 1. So minus 1 minus of again plus 1 gives you minus 2. So you will write it as minus 2 times of r of t minus 1. This t minus 1 because you are going to find out what is the signal change from this point. Okay. So I hope you understand. First step is at this point we are starting from this point because previous in negative side we don't find any signal. We are starting from this point. We understand this is a ramp signal with some slope. We got the slope answer, and so this slope is represented by r of t. Slope is 1. So this is given as 1 times of r of t. And at this point you are having a signal change. It's not taking the same line. It is changing its line. So when it is changing its line, again you find it's a ramp with a slope of minus 1. So minus 1 is the present slope, plus 1 is the previous slope, minus 1 minus of plus 1 gives you minus 2. So I am writing this is minus 2 times of r of t minus 1. And again what you need to do is, it is not extending. If it is extending like this, you will stop at this place. But what is happening? It is stopping at 2. So again what you should do, you should understand it's some kind of signal change only. It's not, the ramp is not always decaying. It is stopping or it is taking the value of 0 at a time t is equal to 2. So at a time t is equal to 2, it's taking 0, means that here you are having 0 slope. So 0 minus of minus 1 is plus 1 now. So you are finding out the signal, there is a signal change at this point. So for this point, the present amplitude or present slope is 0, previous slope is minus 1, present slope minus the previous slope gives you 0, minus of minus 1 is plus 1. So this you will write it as plus r of t minus 2. Okay. So now if you want to, this is the final expression for this signal. Now if you want to validate your signal, so let us say you want to find out what is happening at t is equal to 1. You apply in this equation r of t, okay. This becomes 2 times of r of 1 minus 1, 0, plus this becomes r of 1 minus 2, 1 minus 2 is minus 1. You know very well r of t is t for t greater than or equal to 0. So this is 0 and r of 0 is also 0 and r of 1, sorry, this is not r of t, this is r of 1. R of 1, you know, whatever is the time, the ramp signal will give you the same answer. So if time is 1, r of 1 is also equal to 1. If time is 2, r of 2 is also equal to 2. So r of 1 we are having, so answer is 1. So you have at 1, it's 1. Say for example, you want to find out at a time t is equal to 0.5. Apply in this equation. R of 0.5, okay, minus 2r of minus 0.5, 2r of minus 0.5 plus r of minus 1.5. You are just applying 0.5 in this equation. So you get this one, and therefore you know negative side ramp signal will not be there. So this is getting cancelled, this is getting cancelled. Here you are left with only with r of 0.5. Whatever is there in the inside, r of parenthesis value, the same result only you will get. So because r of t equal to t, you have to understand. So here t is equal to 0.5. So r of 0.5 is also equal to 0.5. So you are getting this answer. At 0.5, your signal will take the amplitude of 0.5 only. Okay. So this is another example. Now let us see some more examples. Say for example, now you are having a slope change. This is 0, this is 1, this is 2. The maximum amplitude now is plus 2. Instead of plus 1, it's plus 2. So now you need to understand the slope. Here dy, change in y-axis is from 2 to 0. Whereas change in x-axis is from 1 to 0. So dy is 2, dx is 1. So 2 by 1 is 2. Here it is plus 2, here it is minus 2. Okay. So how will you write? You are starting again from the negative side towards the positive side. Negative side no signal. So at this point it is r of t, amplitude is or slope is 2. So you will write it as 2 times of r of t. At a time t is equal to 1, you find a signal change. So you have to find the signal change is in this axis, in this direction. The slope is minus 2. So current slope is minus 2. Previous slope is plus 2. So that the amplitude changes minus 2 minus of plus 2. So minus 2 minus of plus 2 is minus 4. R of t minus 1. And if this signal is not stopping, its signal is not growing in the same side. It is stopping at this point and ending at 0. So the slope at this point is 0. So now slope change, there is a slope change. 0 minus of minus 2 is plus 2. So you will write it as plus 2 times of r of t minus 2. This is the expression. So you can validate this expression later. Now next example, let me validate the next example for you. So we have a signal like this. Okay. We have a signal like this. This is 0. This is positive 1. Amplitude in the negative direction. Positive direction. Peak amplitude is positive 1. Peak amplitude here it is negative 1. Let us say this is plus 1, 2, this is 3 and this is 4. Now you want to express. Again as I told you, you are having only a slope here. So you will express this only by ramp signal. There is no unit step signal. Again you are starting from negative side towards the positive side. Before starting from negative side towards the positive side, every time you try to represent what is the slope for the respective thing. So slope of this starting from 0 ending till 1. So dy is 1, dx is also 1, 0 to 1. So the slope is plus 1 here. Here it is ending at 2, 1 to 2. Here amplitude is also 1 to 0. So 1 divided by 1. So here also slope is 1. Otherwise you can do one thing. This is signal which is extending from plus 1 to 3. Plus 1 to 3, you are having a straight line. Actually, I am not able to draw the straight line properly in this pen, but it's a straight line. Okay. So this is a straight line. Assume it's a straight line. Therefore, your slope, you can see what is the dy change. Dy is 1 to 1 minus 1. So dy difference is 1 minus of minus 1 is equal to 2. In x direction also, this place is 1, this place is 3. So 3 minus 1 is 2. So 2 divided by 2, the slope is 1. Since it is coming down, you will write it as minus 1. And finally, when you are talking about this slope, you will understand that dy is, it's 0 here, it's minus 1 here. So dy is, change in y is 1, change in x is from 3 to 4, again 1. So slope is plus 1 because it's rising. So you will write it as slope as plus 1. So now again you will start. So this is r of t with the amplitude is 1. So you will write it as r of t. Now you will find a signal change at 1 time t is equal to 1. Now you have to find out what is the amplitude change. For that amplitude change, the current slope minus the previous slope. Current slope is minus 1. The previous slope is plus 1. So minus 1 minus of plus 1 is minus 2. R of t minus 1. Okay. And that is extending, minus 2 r of t minus 1 is extending from this place to this place. So again you find a signal change only at a time t is equal to 3. So at a time t is equal to 3, you find the current slope is plus 1 and the previous slope is minus 1. So 1 minus of minus 1 gives you plus 2. So plus 2 r of t minus 3. And again you find at the time t is equal to 4, this is stopping. It's not still increasing. It is stopping and the value is 0. Therefore, the signal value is 0. Slope is also 0. So the change in slope, you will find 0 minus of plus 1 will give you minus 1. So the finally it's minus 1 times of r of t minus 4. Now if you want to validate your signal, say for example, I want to know what is this signal at a time t is equal to 3. You apply t is equal to 3 in this expression. This becomes r of 3 minus 2 r of 2, 3 minus 1 is 2, plus 2 r of 3 minus 3 is 0, minus r of 3 minus 4 is minus 1. Now you know our ramp signal is not there in the negative side. Ramp of 0 is also 0. Cancel this. Ramp of 3 is 3. And ramp of 2 is 2. Ramp of 2 is 2. That multiplied by 2 gives you minus 4. 2 into 2 is minus 4. So 3 minus 4 is equal to minus 1. So you can see from the signal at 3 you are having answer is minus 1. So you can also check this, validate this in some other place. Apply t is equal to 1. If you apply t is equal to 1, this becomes r of 1 minus 2 r of 0 plus 2 r of minus 2 minus r of minus 3. You know ramp signal does not exist in the negative direction or negative side. So this is 0, this is 0. R of 0 is also 0. 0 multiplied by anything is 0. So this is also not there. R of 1 is 1. So at a time t is equal to 1, this expression gives you the value 1 which you can validate here. Okay. Next, let us have this combination now. Say for example, you have a signal like this. Say for example, you have a signal like this. Let us say this is minus 2, minus 1, 0, this is plus 1, this midpoint, this peak is plus 1. Let us say this peak is 2. Let us say this peak is 4, this point. Maybe I am drawing it something like not correctly. Please try to adjust. Now let us say this is 1, this is 1.1. Okay, this is 1, this is 1.1, 1.5. Now again, as I told you, we are starting from the negative side. We will end towards the positive side. Find the slope at every place. So slope, this is a ramp signal. So you are going to find the slope. So this is 0 line. the amplitude is 1, maximum amplitude is 1. So in dy it's changing. Dy is 1 minus 0, dx is minus 2 to minus 1. So 1. So 1 by 1, the amplitude is plus 1 here. It's increasing. Here, let us say this is minus 1. Here again, you find amplitude changing from plus 1 to minus 1. So amplitude is 1 minus of minus 1, 2 in the y-axis and 2 in the x-axis, because it's starting from minus 1 to plus 1. 2 in the x-axis. 2 by 2, the amplitude is 1. Since it is decreasing, we write it as minus 1. And you are starting from this point. You need to end at this point. So again slope for this particular sector is plus 1. Why plus 1? Because dy is, here it is minus 1, here it is 0. Dy, change in y direction is 1 time, change in x direction is also 1 time. So 1 divided by 1 is plus 1. And here you are finding a discontinuity. It's nothing but a pulse, discontinuity. So as I told you, for discontinuity, you are not going to find out the slope. Instead, you will find out the amplitude change. So here, amplitude changing from starting from 0, ending at 1.5. So this is plus 1.5, whereas this is minus 1.5. Now let us try to write the expression for this. As I told you, we are starting from the negative side. We will move towards the positive side. So it's at minus 2 is the first signal starting, and it's a ramp signal. So and the slope is 1. So you will write it as r of t plus 2 for this one. And at a time t is equal to 1, you are finding a slope change. So at a time t is equal to 1, the slope change is there. So you have to find out the effective amplitude, which is nothing but the difference between the slopes. So present slope is minus 1, previous slope is plus 1. So minus 1 minus of plus 1 gives you minus 2. Minus 2 r of t plus 1, because your signal is changing at minus 1. Now that is extending till plus 1, and again you find the signal is changing at plus 1. So here the slope changes. Present slope is plus 1, previous slope is minus 1, plus 1 minus of minus 1 is plus 2. So this you will write it as plus 2 r of t minus 1. Then you find this particular slope is not extending. It is stopping at 0 at this point. Then you find a discontinuity. So what you need to do? You need to represent that, you need to stop your ramp at this 0. So again what you have to do? You have to write this slope here. So here it is 0 slope. Here it is plus 1. So 0 minus of plus 1 is minus 1. So minus r of t minus 2. Okay, so you're stopping at this point. Then onwards you can see your pulse is starting or discontinuity. So this you will write in terms of u of t. So this is nothing but 1.5 times of u of t minus 2, because your signal is starting a discontinuity is at 2. So you will write it as plus 1.5 times of u of t minus 2. And you see this is not extending till infinity. Again you find a signal change at t is equal to 4, and the amplitude changes minus 1.5. So minus 1 times of u of t minus 4. This is the complete expression for this signal in terms of ramp and unit step. Now if you want to validate your signal, say for example I want to find out what is the value at t is equal to 3. Apply t is equal to 3 in this expression. So the first expression gives you r of 5. Second gives you 2 times of r of 4. Third gives you plus 2 times of r of 3 minus 1 is 2. Fourth gives you minus r of 1 plus 1.5 times u of 0. Not u of 0, sorry, u of 1. Okay, and here minus 1 times of u of minus 1. So you know unit step signal or ramp signal will not extend in the negative side, so I am cancelling this. U of 1 whenever time is greater than 0, u of 1 will give you, u of any time greater than 0 will give you 1 is the answer. 1 multiplied by 1.1, you will write it as 1.5 here. R of 5. So it's nothing but R of t is equal to 3. T, always remember that. Now R of 5 is equal to 5. Okay, R of 4 is 4 multiplied by 2. So it's minus 8. Plus R of 2 is 2 multiplied by 2. Again it's 4. Here R of 1 is 1. So this is minus 1. This is plus 1.5. So you just add everything. So when you are trying to have 5 minus 8 plus 4 minus 1 plus 1.5, you will get the answer is 1.5. So you can see from this diagram, at the time t is equal to 3, we get the amplitude is 1.5. You can validate this for any time. It's up to you to validate and check the answer. Now I will give you one more example. Same kind of signal only. Same kind of signal. So I think you know how to represent by now. Same kind of signal. This is minus 2, minus 1, 0, plus 1, plus 2, plus 3 and plus 4. Now again let us say here the negative side it is minus 2. The maximum peak here it is minus 2. Let us say maximum peak here it is 1. This point is 1. And let us say this point is 2. Peak. Okay. Now again you start from the leftmost side, go towards the right side, find the slope wherever ramp is coming, find the amplitude change wherever discontinuity point is coming. So here the slope, what is the slope? Peak is 1. In the y direction 1 minus 0, in the x direction minus 1 to minus 2. So x direction also difference is 1, y direction also difference is 1. 1 by 1 answer is 1. Here you find, see here you have to be careful, this looks like extending but there is a slope difference because from minus 1 to 0 it is coming from 1 to 0 in the y direction. Here 0 to 1, x is changing one time but y is changing 2 times. Okay, so separately you will write slope for this, separately you will write slope for this. So slope of this is minus 1 because in y direction the change in y direction is only 1, change in x direction is also 1. 1 by 1 is 1 and it is going down, slope is decreasing, so you write it as minus 1. Whereas for this case in y axis it is 2, minus 2, 0 to minus 2, so difference is 2, whereas in x axis the difference is 1, so 2 divided by 1 is 2 and since it is decreasing the slope is minus 2. Here the slope is plus 2. Then here there is no signal, so slope is 0. Here it's a discontinuity point and the maximum amplitude is 2 and the minimum amplitude is 0. So 0 to 2 plus 2. Amplitude change is plus 2. Here amplitude change is minus 2. Now you try to write the signal. Starting from leftmost side and as usual you know this is a ramp signal and with the amplitude of 1 or slope of 1. So you write it at R of t plus 2. Coming to this point you find there is a signal changing at time t is equal to minus 1 till 0. Again at 0 it is changing with a different slope. So you have to write 2 as this is a 2 different equation. So at the time t is equal to minus 1 you are having a negative slope. Now you know there is a signal change, therefore you have to find out what is the amplitude change. Amplitude change is nothing but difference of the slope change. So the present slope is minus 1, the previous slope is plus 1, minus 1 minus of plus 1 gives you minus 2. So you will write this as minus 2 R of t plus 1 at this point. Now again you find a signal change at 0 because the slope are different. Here the slope is minus 1, here the slope is minus 2. Slopes are different. So again here you find the signal change is there which is given by present slope is minus 2 previous slope is minus 1. So present minus previous, minus 2 minus of minus 1 gives you minus 1 answer. So this will be written as minus r of t because at the time t is equal to 0. Now next again you find a signal change at time t is equal to plus 1. So what is the slope change? Plus 2 is the present slope, minus 2 is the previous slope, plus 2 minus of minus 2 gives you plus 4. So you will write it as plus 4 times of r of t minus 1. Okay, over. Now again you find there is a signal change at time t is equal to 2. So time t equal to 0, current slope is 0, previous slope is plus 2. So you will write it as 0 minus of plus 2 gives you minus 2 r of t minus 2. Then it is extending and again you find a signal change at 3. Now this is discontinuity. Therefore you will represent in terms of u of t. So you know the amplitude change is plus 2. So you will write it directly as plus 2 times of u of t minus 3. And again you find a signal change at time t is equal to 4. The amplitude change is minus 2. So you will write it as minus 2 u of time t minus 4. So this is the expression for this one. You can validate this expression. Say for example, what will happen at time t is equal to 2.5. At 2.5 I have here it is 0. Okay. So 2.5 let us say. Now you have to apply wherever t is there. You apply 2.5. So first expression, first term will become t plus 2.5. Sorry, t plus 2. This becomes 4.5. Minus 2 times of r of 3.5 minus r of 2.5 plus 4 times of r of 2.5 minus 1 is 1.5 minus 2 times of r of 0.5 plus 2 times of u of minus 0.5 minus 2 times of u of minus 1.5. So again the same thing you know very well. U of minus 0.5, u of minus 1.5 is nothing but a unit step in the negative direction which is 0. So I am cancelling this one. Now coming to the first term, it's r of 4.5. R of 4.5 is 4.5 only. R of 3.5 is 3.5 which is multiplied by 2. So this becomes minus 7 minus 2 times 2.5. R of 2.5 is 2.5 only plus 1.5 is 1.5 multiplied by 4 gives you 6. And r of 0.5 is 0.5 multiplied by 2 gives you 1. So this is minus 1. If you add these things, you get 0. Okay. So at the time t is equal to 2.5, here you are having 0 only. So you can validate this for some other time period also. Okay. Now, next example. So we are having a signal like this. So now this is a straight line. Okay, sorry. Straight line. This is a slope. Okay. So let us say this amplitude is 1 and let us say this amplitude is 3 and let this be minus 2, minus 1, 0, plus 1, 2, let this be 3. Okay. Now again as usual what you need to do, you are traveling from the negative side towards the positive side. First apply the amplitude change of the slope change or the slope. So like now this is a discontinuity line. So here the amplitude change is plus 1. This again discontinuity, the amplitude change is minus 1. Let us say this is minus 2. Amplitude here it is minus 2. So now you know there is a slope for ramp sigma. So the slope here it's in the y-axis it's minus 2 to 0, in x-axis minus 1 to 0. So it's 2 divided by 1 which is nothing but 2. Since it is decreasing you write it as minus 2. Here it is increasing you write it as plus 2. Here it's a straight line, discontinuity line. So the amplitude changes 3 from 0 to 3. So this is plus 3. But here it's a slope. So you will write it as a slope. What is the slope here? In y-axis it's from 3 to 0. In x-axis it's from 3 to 1. So it's 3 divided by 2. So in negative direction. So you will write it as minus 3 divided by 2 which is equal to minus 1.5. Now we have written all the values for all the slope everywhere. let us start from the negative side, leftmost side. Leftmost side, it's a discontinuity, so we are going to represent with u, unit step. So this is nothing but u of t plus 2, because the amplitude change is 1. Here the amplitude change is minus 1, because you find a signal change at this point and the amplitude change is minus 1. So you write this as minus u of t plus 1. And from this point, what is happening? From this point, you completed. Now from this point, it's a ramp. So from ramp, you are having the slope changes minus 2. So you will write it as minus 2 r of t plus 1 from this point. Again at the minus 2, it's changing. Okay, so current slope is plus 2, previous slope is minus 2. So amplitude changes plus 2 minus of minus 2, it's nothing but plus 4. Plus 4 times of r of t, because at time t is equal to 0. So you are writing it as r of t. And here what is happening? The signal is not extending. Here you are having a slope from minus 2 to 0. It's a signal, linear signal. It's not extending after 1. Time t is equal to 1. Instead it is stopping at this point. So what you need to do is, you have to write a ramp signal to stop at this point. So that is nothing but you have to assume the slope is 0 at this point and the previous slope is plus 2. So 0 minus of plus 2 will give you minus 2 at a time t is equal to 1. So you write it as minus 2 times of r of t minus 1. Then again at the same time you find the discontinuity. So you have to represent this discontinuity in terms of u of t. So the amplitude change is 3. So you write it as plus 3 times of u of t minus 1. Okay. Then again you find there is a slope from this point to this point, there is a slope. And the slope is minus 1.5. So what you will do, you will write it as minus 1.5 times of r of t minus 1. Because at 1 itself you are writing, at the time t is equal to 1 itself, you are writing for stopping this r of t and increase of this discontinuity, which is nothing but u of t, again starting with a fresh r of t. Okay, then again you find it is stopping, the signal is ending at 3, time t is equal to 3. So for that, the present slope is 0, previous slope is minus 1.5, so 0 minus 1.5 is plus 1.5. So you write it as plus 1.5 times of r of t minus 3. I hope you all, okay, sorry, adjust. It's plus r of 1.5 times of, okay. So if you want to validate this signal, you can validate, say for example, I want to know what is the value at the time t is equal to 2. Time t is equal to 2, it should give me the answer something between 0 to 3, which is nothing but 1.5. So at the time t is equal to 2, you apply t is equal to 2 in this expression. So first part in the expression becomes u of 4, second part becomes u of 3 minus 2 r of 3 plus 4 r of 2 minus 2 r of 1 plus 3 u of 1 minus 1.5 r of 1 plus 1.5 r of minus 1. I am just applying the value of t is equal to 2 in this expression. So I got this expression. Now you know, as usual, r of minus 1, there is no signal existing. So this is cancelled. U of 4, unit step signal greater than 0, the amplitude is always 1. So this give amplitude is 1. Again here this will give you amplitude is 1. Here it's a ramp signal r of 3. So r of 3 is 3, which is multiplied by 2, gives you 6. So it's minus 6. R of 2 is 2, multiplied by 4, it gives you 8. So this gives you ramp. R of 1 is 1, multiplied by 2, it gives you minus 2. Here u of 1, unit step in positive direction is always 1, multiplied by 3, so it's 3. Again ramp multiplied by 1.5, so r of 1 is 1, multiplied by 1.5 is 1.5. So if you add all these things, so you are having 1 minus 6 plus 8 minus 2 plus 3 the result is 1.5. So which is correct. So t is equals to 2. We are getting the result is equal to 1.5. You can validate this for anything. Okay.